Greetings, this is OJambo. In this tutorial, oh boy, I'm going to show you how to get ComfyUI and ready for AI video generation. Now, as you guys know, yesterday I during the afternoon, 2 p.m. Eastern, I showed you how to get started using ComfyUI on Fedora 42 using AMD Instinct MI60. So that was just getting started, and we also installed some models. I showed you how to install models. You basically download them, put them in specific folders, and you copy because I was using SD Next. Just a quick summary. So that worked really, really well. And then at night at 8:30 p.m. Eastern, what I was trying to do was to get the video started. So if you remember, we actually downloaded some models for video. I did one. I think it was 5B. And then we also downloaded another one for 3D models. So then what happened was I tried to generate a video. I chose something which I thought would be very, very small. So everything seemed to be working fine. And then when it was at 5%, the generation, it takes 2 passes. When it was at 5%, what happened is I started noticing the temperature going up. So I said, okay, no problem. So the temperature went up, and then it kept on going up and up and up. I was like, okay, it's fine, because what's supposed to happen is when it reaches 100 degrees, it's supposed to throttle. That didn't happen. So all of a sudden, an alarm rings, and I'm thinking, okay, what's going on here? So then I start panicking. I look at the temperature. It says 512. No joke. 512 degrees Celsius. So I'm like, oh my goodness, and it's beeping. So I panic, and I was live streaming to I was live streaming to obviously YouTube, BitChute, Odyssey, and Rumble. So 4 at the same time. So I switch off. Then I remember that usually when you do a live stream, you can continue. They allow you to have a little break or something, so you can continue. So I started up again. The computer is fine. I tried to go into the live stream, and because I was like, oh, so then I start regenerating the video again. Same thing happens. It took me a while to realize that it was the temperature. So I'll tell you what's happening. So the AMD Instinct MI60 does not have a cooling, it doesn't come with a cooling apparatus. So what I did was I bought a fan shroud. That means it's a 3D printed attachment that goes to that attaches to the GPU, and then a fan can be mounted. In this case, it was a 40 millimeter fan, and that's supposed to blow cool air right through it. And also what I did was when I upgraded my workstation, the case came with 1 fan, but I bought 5 extra CP case fans, 120 mil. So that way there's a lot of airflow. So I thought that would cool it, and it looks like it does, because even yesterday, every time that happened, I was touching the GPU. It was cool. So I was thinking maybe it's a sensor problem. So I did a test late last night. What I did was I finally able to generate AI video, but what I did was I lowered the resolution, because it was 1280 by 714. So I lowered the resolution, and then what I did was I also I measured the temperatures. And then today in the morning I found out that the problem is that I guess the motherboard or the CPU, the maximum temperature it can handle is 100 degrees Celsius. So when anything reaches that, I guess the GPU, when the GPU reaches 100 degrees, it sends a signal, I guess, to the motherboard, and motherboard panics and just shuts it down. So what I did was, yesterday I said when I rendered the video, the AI generated video, I watched how long it takes for the temperature to go down. So the temperature took a very long time to go. It was around 92 degrees. It took a very long time to go to about 60 degrees. So I was thinking, that's weird. How come when I reboot the system, the temperature goes back to about idle 45 degrees? I'm like, that doesn't make any sense. But then today when I was doing some research and doing some experimentations, I found out that every time I switch on the, when I switch on the computer, what happens is that fan shroud, it ramps up to close to the maximum speed, then it obviously quickly goes down to whatever I set it. So that's about 2,000, just below 3,000 RPMs. So that little burst is enough to cool the GPU. So that makes sense, because every time I switch it off, I reboot, then if it's very hot, it will cool down really quickly. So now the thing is, I'm not going to run that 40 millimeter fan at its full capacity of 15,000 RPMs or more. That's crazy. It's like I said, it's like a jet engine taking off. It's too loud. So what I experimented, and that's what I'm going to do today. I'm going to show you what I did. What I did was I found out that there's a driver for the I already forgot the name. I've been working on this all day. There's a specific driver. Let me see what the name of it is. It's called NCT6687D. So that D is actually on GitHub. I guess somebody, the author, what the author did was, because if you're using Windows, MCI comes up with an application, I think it's called Fan Control, where you can actually control the fans and everything on your Windows desktop. But for some reason on Linux, they disable that in the BIOS, which doesn't really make sense. So this person found a way to, I guess, reverse engineer some of the code so you can use it. So it works well. So I'll explain all that when we actually. I'll show you everything, because I said I'm pretty much like an expert on the fans. So what I did was, it might say, "Oh, is that working now?" So I uninstalled it, because what I also found was I had to go to my BIOS and remove the smart fan mode for the GPU shroud, and then then I was able to control the fans, so all the fans. So what you guys are going to see in real time is I'll show you everything, and hopefully I'll be able to control the fan, and things won't happen like yesterday. But don't worry, I'll be monitoring the speed, not the speed. I'll be monitoring the temperature of the GPU today. So this way, if something like that happens, I'll obviously I'll know about it, and I'll stop it. Now I'm also recording this video because I noticed I haven't made any short videos for 2 days now because of this drama. So I need to have something to put there for tomorrow. So this is going to be a short as well. Hopefully it does work. If it doesn't, I guess I don't know what I'll do. I guess I'll call it a fail or something. All right, so let's get started. So as I said before, I got rid of sd.next because that one I was never able to produce a video, even load a video model. It always crashed. So I decided to go with ComfyUI. I copied over one of the standard diffusion models, and I'm pretty happy with it. So this is, you can think of this as a continuation of the live stream from last night. So if you joined me last night, this is a continuation. So I apologize again, it abruptly stopped. I said there's nothing I could do with the temperature, but I said I learned a lot of things, and I'm gonna, hopefully we can take care of that now. So this is live, and hopefully we can sort everything out. So I said I've learned a lot. For some weird reason, I was hoping to get this working using the built-in things that come with Fedora, but looks like I cannot. So unfortunately, I will show you everything and we can all decide together. So let's get started. So the first thing I'm going to do here is, I said this partition here is called AI. It's a partition. What I did was, because I said I have SSD drives, they're from 2016. I bought them used, to enterprise level drives. So I've been using them since. So what I noticed was, because there's 3 of them, 480, 240, and 240. So obviously, the 480 is the one I used for the booting up the system and some other things. But even that way, when you're using like Podman containers, when you're using AI models and stuff, it fills up very quickly. So having a dedicated partition for it is fine. I also moved the Podman. This is all the containers are here, and got rid of SD Next. ComfyUI is really good. It takes up such little space. Remember yesterday I was able to recover about 120 gigs of disk space by getting rid of that. And the weird thing is, I have the same model that SD Next had, and I actually got another model for they copied the models and sensors and everything, sensor tensors over, and I also got a model for 3D, which didn't exist in SD Next. I got a model for video, and it's still taking up less space. Now, to prove it to you, if you're on the command, if I type df-h, you can see right here I'm using 66 gigs with all of that, and that also includes all the Podman containers as well, and the virtual environment for Python. And you can see I still have 140 gig space left. So this was a very smart thing to get rid of. Otherwise, if I still had SD Next, I only have like 20 gigs left, which then isn't very smart. So if you can see here the used, or 66 gigs, and you see I've only used 32%, so I still have a good 66% to go. All right, back here to the command line. So very simple. You guys know this by now. CD into the ComfyUI, and then I type source space -- that means to go back one folder, because we want the Wacom -VE virtual environment, /bin /activate. So there we are. And then somebody asked me yesterday why I'm doing it this way instead of installing everything in, say, in a container all onto the system. The reason I like the virtual environment, because the Python virtual environment, because I can install everything needed for specific application. Like in this case, this is needed for the AI stuff, so it's there. And if I don't need it, I can just simply delete this folder and everything is gone, and I can recover space. And the reason I also didn't use say a Podman container is because when I tried, for example, Easy Diffusion and Automatic 1111, they all wanted to install another version of the Rock M driver. They wanted to install 5.7. When I started fooling around with that stuff, I had 6.13, I believe. Now I have 6.16. So what I'm saying is that by using the one that is on my host system, it will be updated. I update it about once a week. So with Fedora, the constant updates. So that was one of the reasons I also decided not to use a container. Now, clearly, I could have done a container in, say, in Podman, but I said I also, what I found out as well is you're supposed to be able to the container is supposed to be able to detect what the drivers on your host system, but like Easy Diffusion and I said an Automatic 101, they completely refused. They always wanted to install their own version. So I was like, forget it. That's why SD Next was nice, and ComfyUI is even better. Sorry, I shouldn't say that. ComfyUI is fantastic for how much space it uses, and it looks like for if you have small models or you have a lower spec device, looks like ComfyUI is perfect for that. So then after this, you just type Python main python space main.py, and then it will run. If you notice, obviously most of this AI stuff, it's really it's NVIDIA specific. So for example, here it's going to give us an error about some NVIDIA, I guess that's for the Pi audio, but yeah, you don't have to worry about that. So you see that stuff is failing here. I'm going to zoom out a little bit so you guys will read it. You can see it's looking for CUDA. Obviously, I don't have CUDA. I'm using AMD. I have two AMD graphics cards. The integrated one on the Ryzen 5 5600 GT, and the AMD Instinct MI60, which is a 32 gig HBM2 VRAM. The integrated graphics, it holds about 4 gigs, reserves 4 gigs of the regular RAM. So be careful if you're using integrated graphics for things like this, that when it says that you have 30, for example, I have 32 gigs of RAM, it's not really 32 gigs of RAM, because I said it reserves, reserves 4 gigs of that. And then obviously when you're running things like, for example, I'm using OBS, I have some browser windows open, and for example, I'm going to be running a ComfyUI in a second. All of that's going to use a little some RAM as well. So the real usable RAM could probably be like 23, 24 gigs for me as well. All right, now we can see this is the URL we go to. So you can just copy that. I don't need to because we've done this before. So I'm gonna use a Chromium browser here. I just have 127, and there we go. 127.0.0.1:8188. So, and you see here, this is the video mod. What do you call nodes? This is video nodes for ComfyUI. Now, a viewer yesterday helped me with this because I was going back to the command line and I didn't look. So up here, right in the tab, it'll actually tell you the progress bar, and I still don't know why this is like kanji letters. So so what I did here is very simple. I went to templates, and I picked oops, not that one. This is what I did. I went to video AP, no, not video API. I went to video, and I looked through this ones, and I'll tell you which one I picked. It was a guy in a subway, I think, playing a guitar. Was it this one? No, not that one. Oh, where did it go? Was it this one? No, it wasn't that big. It was a small one. I think it was 5B. Where? Oh, this one. This is the one. This is the one I chose. 2.25B video generation. So this is the one I chose, and then what I did, what I noticed was, so then we go back. It's hard to read this. So I might have to change this back to white. I'll close this. So when you click on that, this is the because ComfyUI use nodes. So what I did was, you see here, the width and height. Before it was 1280 by 714, so the width was 1280, the height was 714. So what I did was I changed it 512 by 512, and the length was 121. So just to make sure it works, I changed this to, I think, 3 whatever. It was too fast, and the quality was horrible. So I changed this to 20. I think it says 25, yeah. So I set this to 25, and that one produced something that is almost good enough for a video. I'm going to show that to you. So what ComfyUI does as well is it puts things in the output folder here. So I'll show you what happened yesterday. So we generated all these images yesterday. That's not so important. And then the video. See, there's a video folder. And this is the first video created, and this is the one that was 512 by 512. It was, I think, 3 seconds. So if we play it, you can see it's too fast. So go to properties, and you can see here it's 512 by 512. It's H.264. It's 24 seconds. So it's 0 seconds, basically nothing. And then this one here, which you see it's almost like you can almost see a person there with the instrument. You can see this one is 1 second, because remember it's 24 frames per second. So it's basically 1 second, and it's 512 by 512, the same thing, 24 frames per second. So that's fine. So because one thing I've noticed, so if you don't know, the integrated graphic is used for the streaming, and then the dedicated graphic is used for recording. What I noticed is when the GPU is being used for literally anything else, even something like recording, the AI is very what do you call it? It's not, the quality goes down. I don't know why. it's really strange. So obviously you can't use the CPU, because the CPU will be way too slow. So the GPU is the way to go, but just be aware of that. I found that out. Very strange. So I'm going to leave the same prompt. However, before we run this, I am going to set up a temperature here. I'm going to go to a new tab here, and I'm going to split this tab. Oops, no, that's not what I want to do. Actually, we don't need the ComfyUI anymore, so I think I can leave. Let's see, can I detach this? Move to new window. There we go. So we don't need the ComfyUI anymore. So we don't need this one. So I'm gonna remove this, put it somewhere else, and I'm gonna show you guys the temperature. So I'll clean this up a little bit. Clear. I'm gonna zoom in. So to show the temperature, say I'm using. I'll show you what. So I type rock info. Zoom out, and then you can see that it will show both. That actually surprised me, because all the data I read online, they were saying, oh no, it's only for dedicated GPU. It also works for the integrated GPU. So you see here, this is the Ryzen 5 5600 GT. That's the integrated graphics, and the other one, Agent 2. This one here, you see when it says GFX 9006. That is the dedicated graphics. So actually, let's put this here so people who are on the not mobile, the vertical screens can see. See this one? This is the dedicated graphics. And then this one here, this is the integrated graphics. So that's one thing to do there. Now you can. There's so many ways to take care of this. Don't worry, we'll get to the point. We'll get to the point there. So I want to show you my output of, let's close this. So you see when my output of LSPCI, I just grabbed VGA display 3D and accelerator. So you can see this one here, the first one. That one is the AMD Instinct MI50. Well, it's MI60, but the MI50 and 60. I think 60 is just a little higher clock speed or something like that. But yeah, it's 32 gigs of RAM. And the other one is you see it says mobile series. That's the integrated graphics. Okay, and what else can I show you? So, I wonder if I can do this right now. Okay, so you know what, I'm gonna leave this because I do need to show you guys something else. I'm gonna leave that for later, when something is running. So I'm going to, why can't I move this to another monitor? Move to a new window. So we'll come back to this one, because when things are running, you guys will see. I'm gonna make this smaller. So this one, I'm just gonna show you the I'm going to show you the temperature. Okay, so you just type rocm -smi, and you just say show temp graph, I think it is. 2 hyphens. Yeah, so this is, you see, GP0 is the dedicated one. Or the Instinct, and this one, which is 32, is actually the integrated graphics. It's kind of funny because the integrated graphic is the one with the CPU, and the temperature is actually lower than on rest, then this is the GPU. So I'm okay. 45 degrees is perfectly fine. It's it's perfectly fine. Obviously, I can cool it further if I had the shroud fan running higher, but then I don't care about the noise. So that's perfectly fine. And remember also there's the 6 case fans as well, so they will help dissipate heat. So we're gonna pay attention to this one the most. Okay, watch how quickly the temperature is going to spike up. Watch how quickly the temperature here is going to spike up when I start actually doing a video. So because I'm also recording, the temperature should be fine, but just be aware that if the temperature goes to about 95, 96, I'm going to shut down. I'll shut down ComfyUI. Because I don't want, what happens is if this goes to 100, it's going to trigger an alarm. It's going to be really loud and annoying, and it takes a while for this guy to, I said, to go down. So with that said, let's get started here. So I'm just going to hit we'll go back here, and I'm going to hit run. Actually, you know what, let me actually also I'll bring up the task manager as well, so you guys can see how many resources ComfyUI. You see, ComfyUI is takes so few resources. I'm going to put this up here. There we go. So you can see what is going on here. More here, so you guys can see what's going on. So you see the remember GPU 0 is the MI60 Instinct. This is the integrated graphics. All right, now that's said, and you can see even with OBS running, you see how much memory. I was telling you about the memory here. So I have 32 gigs of RAM, but the integrated graphics reserves 4 gigs of that. So that's why I'm saying, like, you don't really get 32 when you're having integrated graphics. And I said we're running programs, you might be lucky to get about 33, 34, what I'm saying, 23, 24, just that when you're actually working. All right, I'm gonna click this. In case you want to know what it's saying here, it says low contrast and intro 1970s style subway station. A street musician plays in dim lights and rough textures. He wears an old jacket, playing guitar with focus. Commuters hurry by, and a small crowd gathers to listen. The camera slowly moves right, capturing the blend of music and city noise, with old subway signs and moated walls in the background. So then below that, where it says clip text encoder, negative prompt, it's all in, it looks like it's kanji. I'm not sure if it's Japanese or Chinese. So you see the temperature here, it's 55. Look how quickly it jumps up. You see it's already at 60, right? And you see it's at 15%, 20%, the progress bar. The temperature is already at 70, okay? So it's going to jump to 90 in a blink of an eye. You see jump, probably 88, then it will slow down. So I expect this to jump to this to be 95 because I said I'm also recording a video as well. And hopefully it doesn't crash and it can finish. So it's at 50%. It does 2 passes. So it's 80. I'm actually surprised it stopped there. Okay. All right. So this is another reason why, obviously, using consumer cards which already have a cooling system are not too shabby. Now, I said there are workarounds. We'll talk about that today. That's what this live stream is about as well. You can see it's inching towards 90. I'm actually surprised it took that long because, yeah, when I was testing this, it was just jumping. Okay, so it's still at basically 90 now, 90 degrees Celsius. So at first I thought maybe something is weird because I can touch the GPU, so I'm thinking maybe the sensor was broken or it's in a weird place. Is it done? Oh, I was just loading the model. Oh, I'll show you what's happening here on the command line. I have to make sure I pay attention to that. So here in the command line, you see it loaded. It says it loaded 100%. The prompt is, oh, it's done. I am blown away. I am dumbfounded. I am dumbfounded. Could it be maybe because it's cool here now inside the room also? I am really dumbfounded. This thing was constantly going to like 95. Yeah, so it finished. I am really dumbfounded. Holy moly. Okay. And so you see how quickly it went up to, and it's going down even faster because yesterday was taking its sweet time going back down. So, okay. So you see the problem is this is just 512 by 512, and you see how quickly the temperature went up. So be careful when you get this server GPUs, is that you have to watch those temperatures. They will spike up very quickly. But what is supposed to happen is when it reaches about 100, it's supposed to throttle. But I said in my case, it just hit the alarm and was super annoying. If you guys watch the video from last night, yeah, you see why. So if you notice, it's actually going down much faster than I expected as well. Wow, okay. So here's the thing. I would not run another model until it reaches about 60, because when it reaches 60, it's going to definitely jump to like 95. So I would wait until it's about 50, and then I would run another test. So I'm going to wait for that. So while that's waiting to cool down, I'm going to show you. So you see here, it created the video. Oh, I don't know if let's see the code of the video it created. Holy, that's actually not bad. You can actually see the subway platform and everything. Of course, it's very fast, and the quality is right, but it's still not. It's not too shabby. So what I'm going to do is I'm going to play. Let's see. 1280 by 714. It's close enough to 16 by 9. So maybe it works best in a wide what do you call it? Wide dimension. So I believe, if my math is correct, what is 512? Okay, I guess I gotta do some calculations here. Oh, I should open up the calc. Oh, let me open up the calculator. Do I have a calculator here? Okay, there we go. So 16 by 9, that should be 9 by 16. So we should say 512 times 9 divided by 16. No, okay, it's the other way around. I knew I screwed that up. How do I do this calculator? Okay, so let's do 512 times 16 divided by 9. 910. Okay, let's try that one. Let's try 910 by 512. That one, ooh, that one's gonna be fun. I think that's too big, but I'm good. So what is it? 910? 910. So it made it 896, which is perfectly fine. I don't know how it does this. I think it goes by multiples of, I don't know what type of multiples it does, but that's fine. It's a little bit smaller. So as I said before, I'm going to wait for it to jump into the 50s before I run that again, because I know that's definitely going to be in the 90s. So I'm going to wait for this to cool down to at least 50, 50 something, like 55. Actually, I'm actually surprised. It's dropped down much faster than I expected. I said if I reboot, it will be because the fan will hit up to maximum temperature, and then it will obviously cool down to its 45 degrees or etc. All right. So one of the problems with this MSI motherboard, which is the B50A Pro series, is that, as I said, for it doesn't have on Linux. It doesn't allow you to control the fans, but a smart person was able to do some reverse engineering with and able to get it. So I tried the driver and it actually worked very well earlier today. But then I wanted to make sure that, so the problem is I didn't want to compile it, because as I said, I'm using Fedora Linux, so meaning that about every 2 weeks or so, 2 or 3 weeks, they come up with a new kernel, so I don't want to recompile it. So I was trying to figure out if I can get this working using just what's available, and I'll show you that right now. So I know I have, oh yeah, this one here. Oh, I didn't, if you guys pay attention to the memory spike, I'm going to wait a little bit and then I'll run it again. So while that's going on, I'm going to show you exactly what I did here. So you can see, as I said, the radian. So it's the first one that shows up. So that's 0. So there are multiple ways to do this. One way is to load modules. So for example, if I type sensors, I'm going to zoom out a little bit because there are a lot of sensors here. So the sensors, you can see all the sensors here for the fans. Now we can tell which one is which very simply by see right, this one here, the 2739 RPM. That's obviously the fan shot, and it's a 40 millimeter fan. So so basically what we want to do is this fan right here, which is a 2739 about-ish RPMs. That's the fan we want, that's connected to the GPU. The problem is we need to get the GPU temperatures. Like for example, you see right now it's 50. So what we want to do is this one is set, if you want to know, in the BIOS it's set to 1%. So that's 30, 40 degrees. So I count that as a baseline. However, you see when it's like 56, I would like to ramp this up to say 3000 or 3200 RPMs. So that's the plan. As I said, unfortunately, there's no way to do that in a BIOS, and because by default MSI doesn't allow us to control the fan on Linux. That would have been really nice out of the box, because if I was there, I would be able to type, because you see I'm able to get the GPU temperature here. So then I would say, hey, the temperature is, say, less than 50, who cares? If it's greater than 50, especially 55, 56, then what I want to do, I want to ramp this up. So it's a very simple, you can write your own script or GUI. They're very, very simple to do. And I said I can just ramp it up manually. I'll show you how to do that as well. But the problem I said is I can get this temperature, I can get this temperature. What I need to do is control just one fan. I don't care about the other fans because I can control them in BIOS. They're perfectly fine. So this is the fan that I do want to control. Okay, so I'm waiting a little bit lower for this one before I run it again, so don't worry. So this is the fan we want to target, and is this these sensors. And as I told you before, I was able to get the sensors by enabling one module, a kernel module, and I'll show you where that is as well. So what you do is very simply you have to look inside your current your kernel to see what modules are available, and then you pick one of them. So so this is how you that one. Where is it? It's just a second. Oh yeah, here it is. So this is the command you run, and it will show you how to what modules are available, and then you can just run a mod probe. So if I paste this in here, you see all that stuff in red. What's that one? PM bus. Okay, so these are the modules. So what I did was I enabled this one right here, this one 6683 NCT 6683. That's the one that enabled the sensors to be read. Before that, you could not read the sensors. So that one allowed me to read the sensors. However, that one does not allow me to control the fans. So that's a nuisance. And you can, if you notice here, back to the code, when I run the sensors, it tells us what mine is. You see, mine is a 6687. So the problem is, if you look in here, there is no 6687. There's 6683, and that's it. But there's no 6687. Now, some people are saying that that if I install this one, the 6775, that one will have that one should work as well, or I can compile the 6686. No, 6687. Yeah. So I'm probably I might have to do that again. I did compile earlier and it did work, and I said the problem I don't want to do that is because every time there's a kernel update, I'll need to recompile it. So I do not want to do it that way. And the other one I tried, which I'm going to remove in a few seconds, is there's one called fan-pwm. So that's one I also tried to install. Where's P? And O. Yeah, this one. No, this one here. pw-fan. This one I've tried it twice. It does not work. So I'm going to actually just remove this one. Okay, so the temperature is about 50. I'm going to wait just another second, and I'll take care of that. So if I type ls mode, and I pipe it into grep, and I look for NCT, you can see there's only one. It's the 6683. And then you can also obviously type mod info. I can type was it NCT 6683, and you see it has been signed, and you can tell by Gutner Rock, and you can see it's the NCT 6683D driver. The D obviously stands for driver, in case you didn't know. So that's a license, so that's fantastic, and this came by default by installing the kernel. Now, well, this it depends on nothing. Great. So, and then the PWM fan, you see that one also is the Fedora kernel signing key, and that one was by Camille, and you can see it. That's the alias. It's a platform PWM. See, the name is actually PWM_fan. This confused me because when I was trying to remove it or see if it's actually installed, it's actually _fan. So I just be aware of that. So this is the one that you see. This one has been installed. So I'm going to remove this one as well. Oh, here Hikaras game channel and computer technology morning or night, depending on how's the video generation going. Yeah, so I managed to get video. I did manage to get some videos. Actually, I've just generated a video. I'm actually going to generate another one. I'm just waiting for the temperatures to go down, and I was just explaining that what I do want to do is I want to tie the shout fan to the GPU instead of relying on the BIOS, because the BIOS is way too slow, or it actually doesn't work the way as intended. I tried using the CPU, but that is not accurate, because the CPU temperature only goes up to, for my testing, it only goes up to 50 degrees. So that's not good enough, because if you can see the GPU right now, it's already at 50 degrees. So the CPU is not a good indicator. So either I need to get a fan controller. But from what I'm reading, I don't think fan controllers will suit me, because I do like the manual switch, but then again, the good thing about the manual is, for example, if I'm going to run like AI stuff, I can quickly I can dial it up, but I would like something that's more automated. But I don't feel like spending like $200-300 just for a fan control. That's crazy. I'm saying is, if I can figure out how to do this, which I said I already solved it earlier today, I would rather go that method instead. So so my only dilemma is, I don't want to install, I said I don't want to be compiling every 2 weeks or so. I mean, I can, but I said I don't want to, because what I've noticed is sometimes the software that you compile, especially in the kernel stuff, it might be a little bit outdated, or sometimes even it might be too new. But most likely, because I'm running Fedora, it's going to be outdated. So I don't want that. So I'd rather have something that comes with Fedora built in. So if you're joining us right now, yeah, that's another option as well. I could also get a little something to its own little temperature thing. But again, I want to keep things extremely simple, and I think if because I found out how I can control the fans, I can write a simple script. It could be Bash script or Python script, or it doesn't matter, any scripting, and that should work for me. I can even just do it manually. Like, for example, if I'm going to generate a video, I can just ramp it up myself. So just on the command line, which is perfectly fine. I can do that. So I'm hoping in today's tutorial, I'm gonna, since yesterday, we had that little drama. I think what I'll do is I'll show you guys what I did earlier today, and then I'll end this video by doing something which is probably not too smart. Hey, I should actually put a disclaimer. I should say, don't try this at home. Okay, I'll make sure I remember that. If I forget, I've warned you guys. So I'm gonna try something different before before this live stream is over. But I gotta warn you guys: do not try this at home. It might completely fail and bonk your system. Now, because I'm on Linux, a simple reboot, or I can just I can also what do you call it? I can always revert back, just reinstall everything. So it's not like in Windows or Mac or something like that. All right. Now, with that said, so I'm going to remove this pwm_fan. So one of the problems is if you go list mode, and then you grep for what is it, pwm-fan, you see nothing shows up. The reason is because it has that underscore. So this one was, this one here, see this, it's actually, the name is actually underscore, but everything is with hyphen. So that was because I was searching for it, it never worked. So the way I found it is when you put the asterisk, and you see it's pwm_fan. So I'm going to remove that. So to remove something, you just type mode probe space -r. R for now is to remove. Then you just type pwm_fan. So it's not going to allow me because I have to do a sudo. You have to be root. I'll type in a super secure password, and it's gone. So for example, if I type, you see it's gone. So that's what we want. And I'll show you, so just at NCT, I think there should only be, yeah, there's only one. This is the one I was telling you guys about, 6683. That's the one that allowed me to get the sensors. Unfortunately, it doesn't control sensors. And I'll show you how I know it doesn't control sensors. The reason for that is if you type, where is it here? Ooh. So you simply, okay, so the first thing you do is you get all the hardware monitors, paste. So you see this, let me zoom in a little bit. So here we go. So in /cys/class/hwmon, that's obviously hardware monitor. You see there's 0, 1, 2, 3, and 4. So there's 4 of them. Now, what you need to do is you have to find out, you want to find out the names of them. So what you do is just use the cat command and go through all of them. But the good thing about cat is you can piggyback on top of each other. So you can just do it at once. So this, you see here. So this tells me that, I'll explain what all this means. So the first one, which was 0, that one is NCT6687. So that's very important. Remember when we did the sensors, it told us that's the one. So that's the one. We don't have a driver for that one yet, but that's the one where all the fans and everything will be. And then you see here we have the AMD GPU. This is obviously the dedicated one, and I'll prove it in a second. And the second one here, this is the integrated ones, and then we have something else, temps, and this one is the Wi-Fi one. So Wi-Fi one we don't care about, that's a dedicated card, because the motherboard didn't come with Wi-Fi. I had to use the Wi-Fi card from the old workstation. So now, because I'm always going to use the ROCm driver, so I'll be reading the temperatures from here, but you can also read the temperatures from here as well. But I'll just read it from here. It's just simpler because I'm saying I'm always going to have it. So I can read it from here. I can also read it from here, or I can read it from the sensors. It's up to you how you wanna do it. So the good thing is I can read the temperature. That's fantastic. So unfortunately, I can't control. The fans, and I'll show you how I know I can't control the fans, because so now we know it's in HMON 1 or 0, so HMON 0, that hardware monitor 0. So what you do is you just list whatever is inside there, and we look for the word enable. So if you see here, remember we want fan 4, and you can see here we have all this stuff, the fan inputs. Obviously fan 4 is here, input, main, pulses, and then it's tied to PWM4. But the problem is there is no PWM4 underscore enable. So that's the reason we need to install the proper driver for it. Now, so I'm going to show you where you can get the driver and compile it yourself. So what I did was, on GitHub there's a Fred 78290. Yes, I know. So I'll go here. Do I have the browser open? Yes, I do. So we'll go here on GitHub. So this is Fred 78290. He created a driver. See, it's the NCT 6687D. So this is the D obviously stands for driver. It's a kernel module, and he explains here this module permits to recognize the chipset Nuvuton whatever NCT 6687-R in LM sensors package. The sensor is present on some B550 motherboards such as MSI or ASUS. So remember, I have an MSI B550A Pro. So he gave the instructions here. Now you guys have seen my tutorials, you know full well you should be smart. Don't just don't just clone this. Always put a depth one, because for example you see there's a main, you see there's several branches. Look how many branches there are. So you don't need all those branches. Just pick the top one and you'll be good to go. So just put depth one, you CD into it, then you simply make AK mode, and then the dependencies. Now I believe I should have all these dependencies already, because I tried this earlier today. Some of them might have been deleted, but I can reinstall them. So for example, it says here Fedora, CentOS, REL. You have to install this. I think I already have this installed, I said. And then so there's two ways you can build this. Obviously you can use, this is for the deb file. I don't care about the deb file. RPM. So I have RPM. So it simply make AK mode, or you can do the, that's if you want to create a RPM file. If you just want to do the manual install, you do it this way, and you have it running. So the way I did it before, believe it or not, I did two stupid things. I installed it this way, but since it wasn't working, then I thought I had removed it, which I did not. Then I also installed it using copper, repository. Because when I thought I removed it, it was reinstalling itself and it was driving me crazy. So as I said before, you have a couple ways to install it. So I'm going to install it. I'm going to install it using DKMS, and I'll do it using the make install. So I think this is probably because this was working, but I'm curious because since I really want to. So this is what I recommend you guys do. And then you'll be able to enable it, and we can actually you can also have a GNOME extension. I'm using GNOME, and then you see the temperatures here. I do have a program. I've shown you guys this before. The program is called Fan Control. I've installed it using Flatpak. You see this is the one here. It claimed that it can control the fans, but I was never able to see. This is the fan. You can tell fan 4. It's one of the highest RPM. I was never able to get it to work. I do not know why, because when I click it, I don't know how you're supposed to get this to work. You just delete it, so I don't know how you're supposed to get that to work. Can I add an item, graph, variables, wow, really? Okay. Monitor attention, monitor fan, assign a certain behavior. Maybe this will work, because when I was running this program before, it was saying just put some udev rules, which I did. I'm wondering if it's going to work now. So let's try it. Okay, so take 5 variables. Okay, let's do that. Okay, where did it go? Oh, here it is. Linear. What does that mean? Linear. None. Oh, there's more stuff here. Okay, so I don't know which one to use. Temperature 1. See, that's for the Wi-Fi. I don't care about the Wi-Fi. So it looks like it's not able to control it because I don't see. Yeah, it's not here. Yeah, I would love to be able to do this. Is it because I have to delete it here? I'm not sure. Junction memory. Oh, this is a GPU. Yeah, but the GPU, this doesn't help me because the GPU doesn't have, it's not tied to, I guess this is to add things it hasn't added here itself. But the problem is, how do I, yeah, this is here. This is also confusing. Is this tied to this guy then? Yeah, so I don't know how to use this program. Graph returns a fixed value, defines the high. That's the one I just did. Monitor temperature sensor, monitor, assign a certain behavior to a certain. Yeah, that would be nice. I would love to assign this to. Okay, let me try that. Control 1. Okay, nothing happened here. Okay, so that is not working. Most likely, the reason it's not working is most likely because the driver is not working. But that would have been nice. That's basically what I want to do. So obviously that doesn't work. And these are just sensors. Again, I don't care about sensors. I want to be able to control them. So let's probe sensors on boot. Okay. Anyway, so I am torn. You know what? I'm gonna try it. Okay, I'm gonna try it. So what I'm gonna do is, where is that one? So the temperature is down here. Sorry about that. I forgot about the video. I apologize. So let's go and generate a video. Where is it here? Let's go generate a video. So I'm going to generate a video again. The temperature is low enough. It's almost back to yes, Hikaros. I plan on I do plan on setting it's already set to manual in the BIOS. So that way I can control it here. I said I did test this earlier today. You can't use the smart fan mode. You have to turn it off. I turned it off for this particular fan, so that way I'm able to control it here. Okay, so as you can see, look how quickly the temperature jumped up. Did I tell you guys? I said in the blink of an eye the temperature will jump up. You see how quickly it jumped from 47 to 82, and at least it's doing something up here. So this is definitely going to hit the 90s. Yeah, let's wait. Fingers crossed. So this is why I waited, because if I had run this when it was 60, it would have definitely been in the mid 90s. So you see, it's definitely going to hit 90. And you see how long it took to get down to about the normal temperature. Definitely going to hit 90. So once it hits about 94, 95, I'm not going to take any chances. I'm going to shut down the ComfyUI. Yeah, it's definitely going to hit 90. See, was I right or what? Come on, hit 90. There we go, 90. I told you guys. So that's why I said make sure you monitor the temperatures. I'm 100% sure it's probably going to hit at least the mid 90s here. Okay, 92. Yeah, so that's why I waited until it was in the 40s. Because imagine if I ran it onto 60, it definitely would have hit 100 degrees Celsius, and then the alarm would have come on. So it's already 93, which is dangerous there. But 94, it's 85%. One thing I noticed, usually when it's like 96%, I was checking out, then immediately jumps to, ooh, it's 90%. Is it gonna make it? Oh, fingers crossed. I don't think it's gonna make it. 90, come on, be 95. 95, come on. Okay, okay, this is way too dangerous. I might have to break. I think I have to crack this open, close this. Okay, I'm ready. I'm gonna have